Welcome to Nihal Academy. This is your physics mentor Pavan. In the previous class, we discussed series connection and parallel connection of resistors. Now we'll see the problems on the series connection and parallel connection. Here the problem is a resistance of 6 ohm is connected in series resistance of 4 ohm. The potential difference of 20 volt is applied across the combination. Calculate the current in the circuit. And the second problem is potential difference at 6 ohm resistance. So this problem contains the two questions. The first question is current in the circuit we have to calculate, and second one potential difference at 6 ohm resistance we have to calculate. So first we will write the given data. So based on the given data, so resistance R1 is equal to 6 ohm, and the second resistance that is R2, it is given 4 ohm. Now these two are connected in series and the potential difference is given. So potential difference shortcut PD, that is V is equal to, it is given 20 volt. Now we'll see the diagram for this. So take the two resistances. This is the first resistor, that is R1, and the second one, it is connected in series, this is R2. Now these two are connected to the potential difference. This plus minus, and the potential difference is 20 volt, and it is connected to the plug key. Now this is the current direction. Current is I. So R1 is given 6 ohm and R2 is given 4 ohm. So to calculate current I, we have to first calculate the resultant resistance of R1, R2. Now these two are connected in series. So in series connection, the resultant resistance or net resistance or effective resistance or total resistance RS is equal to, what is the formula? R1 plus R2. And now we'll substitute the values 6 and 4. R1 is 6 and R2 is 4. Now substitute the values 6 plus 4. So this is equal to 10 ohm. So the resultant resistance R, it is equal to 10 ohm. Now we have to calculate that first question. What is the first question? Current I. So current in the circuit I is equal to question mark. So as per Ohm's law, how can you write? So V is equal to IR. So from this current I is equal to, this is multiple, send to the left side, then V by R. So I is equal to V by R. So what is V here? The potential difference. So the potential difference is here, it is given 20 volt. So that is 20 by the total resistance, that is equal to 10 ohm. Cancel 0 on 0. Now this is equal to 2. So what is the unit of current? Ampere. So A is the letter to represent the unit of current, that is ampere. So the total current passing through the circuit is 2 ampere. So in the second question, we have to calculate potential difference at 6 ohm. So here the resistance R is equal to 6 ohm and the potential difference V we have to calculate. Now look at the diagram. Here R1, R2 are connected in series. So same amount of current passes through the two resistors, that is equal to 2 amperes. We know that in series connection, current passing through the resistors or resistance is constant. So that's why I is equal to 2 amperes. So we know that here current I is equal to 2 ampere. So as per Ohm's law, so V is equal to IR. Now we have to calculate the V. I is given and R we know the 6 ohms. So you have to calculate the potential difference at 6 ohm. So this is the potential difference V at 6 ohm. So this is the resistance R1, that is 6 ohms. Here we ask you to calculate the potential difference. So now R1 is equal to 6 ohm. So from this we can write what we have to calculate. V is equal to IR. So I is equal to 2 into the R, it is equal to 6. So 2 6 or 12. So V is equal to 12 volt potential difference. So this is the potential difference at 6 ohm. It is equal to 12 volt. Now we'll see the second question. If three resistances R1, R2 and R3 are 5 ohm, 10 ohm and 30 ohm respectively are connected in parallel in the circuit and the potential difference is 12 volts, then calculate total current passing through the circuit. Here the three resistors are given. These three resistances are connected in parallel and the potential difference is given, that is 12 volts. Now we have to calculate the total current passing through the circuit. So first write the given data. Resistance. So what are the resistors? R1 is equal to 5 ohm, R2 is equal to 10 ohm, R3 is equal to 30 ohm, and the potential difference PD, it is nothing but voltage V is equal to 12 volts. We have to calculate current. I is equal to question mark. So here R1, R2, R3 are given and the potential difference is given. We have to calculate the current I. So we'll see the circuit. So parallel connection. So parallel. Here R1 is equal to 5, R2 is equal to 10, R3 is equal to 30 and the potential difference is 12 volt. So we have to calculate the total current passing through this circuit. So to calculate the current passing through the circuit as per Ohm's law, V is equal to IR. So I is equal to V by R. V we know that, but R we have to calculate. That is resultant resistance. So it is equal to the 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So in the parallel connection, resultant resistance 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Now we will substitute the R1, R2, R3 values here. Is equal to 1 by R1 is 5 plus 1 by R2, that is 10 plus 1 by R3, that is 1 by 30. Now we have to find out the LCM of these three, that is 1 by R is equal to, so 30 is the LCM, then this 5, 6 times cancel, so 6 into 1, 6 plus, and the 10, 3 times cancel, 3 into 1, 3 plus, and this 30 1 time cancel, so 1 into numerator 1 here, 1. So this is equal to, so 9 plus 1, 10, 10 by 30, 0, 0 cancel. Then now So 1 by R is equal to 1 by 3. So from this R is equal to 3 ohm. So this is the total resistance or resultant resistance in the parallel circuit, that is R is equal to 3 ohm. Now we have to calculate the current passing through the circuit. So as per Ohm's law, we can write V is equal to IR. So from this I is equal to V by R. So the total potential difference of the battery V is given, that is 12 volt. We know that in the parallel connection potential difference is constant. So that is 12 volt by the total resistance is 3 ohm. So 4 times cancel. Then the current I is equal 4. The unit of current is ampere. So A. So what is the total amount of current passing through the circuit? That is 4 amperes. Total current I is equal to 4 amperes. Now we'll see the next question. In the circuit diagram given below, three resistors R1, R2 and R3 of 5 ohm, 10 ohm, 30 ohm respectively are connected as shown. That means parallel connection. Calculate current through each resistance. Second question, total current, and third question, total resistance. So three are connected in parallel and the potential difference is given. We have to calculate the current through each resistance. That means here the current passing through this is I1 and here it is I2 and this is I3. So we have to calculate I1, I2, I3 and total current I and third one total resistance R. Now we'll say that. So write the given data. R1 is equal to 5 ohm, R2 is equal to 10 ohm, R3 is equal to 30 ohm and V is equal to 12 volt. Now what we have to calculate in the first question? So how to calculate current through each resistance? We have to calculate I1. The first question, I1 is equal to, as per Ohm's law, I is equal, how V is, as per Ohm's law, V is equal to IR. So we can write I is equal to V by R. Here potential difference is constant. So V by R1. So what is that V value? 12 by R1 is 5 ohm. So this is equal to 5, 2 times cancel. So 5 to is 10 and decimal. So remainder is to 20. So 2.4 amperes. This is. So I1 is equal to 2.4 amperes. And next, I2, how can you write? It is equal to V by R2. So V value is constant. So that is 12 by R2 is, that is R2 value is 10 ohm. So this is equal to 1.2 amperes. So the current I2 passing through the second resistance R2 is equal to 1.2 amperes. So I2 is also calculated. That means current passing through the second resistance is 1.2 amperes. Now I3, it is equal to V by R3. So V value is 12 by R3. R3 value is 30. So 12 by 30. So 3 here, 4 times cancel, 3 here, 10 times. So 4 by 10, that is equal to 0.4 amperes. So I3 current is equal to 0.4 amperes. Now, so first question is complete. Current through each resistance, I1 2.4 amperes, I2 1.2 amperes, I3 0.4 amperes. So therefore, so current through each resistance, current through each resistance I1 is equal to 2.4. I1 is equal to 2.4 ampere. I2 is equal to 1.2 ampere. I3 is equal to 0.4 amperes. The first one is completed. So already in the first problem we calculated I1, I2, I3. Now how to calculate total current? So total current I is equal to I1 plus I2 plus I3. Now we'll substitute the values here. So I is equal to I1 2.4 plus I2 1.2 plus I3 0.4. Now we have to add these three. This is 4 plus 2 6, 6 plus 4 10, 0 and 1. So 3 plus 1 4. So 4.0. So therefore I is equal to 4 amperes. So the total current I is equal to 4 amperes. So we have to add the I1, I2, I3. If you add I1, I2, I3, it is equal to total current I. I is splitting into I1, I2, I3 in parallel connection. So I1 current is passing through R1, I2 passing through R2, I3 current passing through R3. So if you add I1, I2, I3, then you will get the total current I. So that is 4 amperes. Now third question is total resistance you have to calculate. The total resistance R as per Ohm's law. So V is equal IR. So R is equal to V by I. So what is V? The total potential difference. The parallel connection potential difference is constant. So that is 12 by, and total current is 4. So 4 3 times cancel. So then R is equal to 3 ohm. So the total resistance in this circuit, it is equal to 3 ohm. Now we'll see the next problem. R1 is equal to 10 ohm, R2 is equal to 40 ohm, R3 is equal to 30 ohm, R4 is equal to 20 ohm, R5 is 60 ohm, and the potential difference is 12 volt. Calculate total resistance and total current. So R1, R2 are connected in parallel, R3, R4, R5, these are connected in parallel. So first you have to calculate the resultant resistance of R1, R2. Next, we have to calculate resultant resistance of R3, R4, R5. So parallel. So 1 by R is equal to 1 by R3 plus 1 by R4 plus 1 by R5. Here 1 by R is equal to 1 by R1 plus 1 by R2. So after that, the resultants are in series. Then we have to calculate series connection. So first we will calculate the resultant resistance of R1, R2. Now we will take the first case, that is R1 is parallel to R2. In the resultant formula, so 1 by R, so there are the two cases that are in the parallel connection. So this resultant will consider as R dash. So 1 by R dash is equal to 1 by R1 plus 1 by R2. Now substitute the values. 1 by R1 is 10 plus 1 by R2 is 40. So the LCM of these two is 40. 10 4 times cancel. So 4 into 1 4 plus 41 times 1 into 1 1. So this is equal to 5 by 40. Now 1 by R dash is equal to 5 here, 8 times cancel. So this is equal to 1 by 8. So therefore R dash is equal to 8 ohm. So we have calculated the resultant resistance in this connection R1, R2. Now we have to find out that R3, R4, R5, these three are also in the parallel. So resultant resistance of these three we have to calculate. So we have to calculate the resultant resistance of R3, R4, R5. Now again these three are in parallel connection. So 1 by R double dash is equal to 1 by R3 plus 1 by R4 plus 1 by R5. So this is equal to, now substitute the values. 1 by R3, R3 value 30 plus 1 by R4 20 plus 1 by R5 60. So the LCM of these three is 60. So 30 2 times cancel. So 2 into 1 2 plus 20 3 times cancel. 3 into 1 3 plus 60 1 time cancel. 1 into 1 1. So this is equal to 4 plus 2 6. 6 by 60. Then 60 means 6 1 time and here 10 time. So this is equal to 1 by 10. So therefore 1 by R double dash is equal to 1 by 10. So R double dash it is equal to 10 ohm. So we calculated that R dash and R double dash. Now see that here R dash is equal to 8 ohms, R double dash is equal to 10 ohms. That means R dash is the resultant of R1, R2. So instead of R1, R2 we can draw that resultant. This is R dash 8 ohm and connected to ammeter, and now the resultant here it is 10 ohm. This is R double dash 10 ohm and the plug key and battery. Now if you look at the board, now the resultants R dash and R double dash. This first end connected positive of the battery and the second end connected to the end of the second resistance and the connected to the negative of the battery. So this is called as series connection. So now we can understand that R dash and R double dash are in series. So the resultants are in series now. So the resultant formula for the series connection R is equal to R dash plus R double dash. So now R dash value 8, R double dash value 10. So this is equal to 18 ohm. So R is equal to 18 ohm. So the total resistance, therefore the first problem is solved here. So what is the answer of first one? The total resistance R is equal to 18 ohm. Now second one, B, total current. So we know the total resistance and total potential difference. So we can use the Ohm's law. So we have to calculate the current. So as per Ohm's law, V is equal to IR. So V value, we know that, R value we know. So we can calculate I value. So from this I is equal to, how can you write? Is multiple center other side. So that is divisible. So V by R. So here V value is given, that is 12 volt. So we can take it 12 by the total resistance, it is equal to 18 So 12 by 18. 6 2 times and 6 3 times. So 2 by 3. So this is equal to 2 not divisible by 3. So put 0 and decimal not 20. 3 6 times 18. The remainder is 2 again 20. So 0.66. What is this current? So the unit of current is ampere. So therefore current I is equal to 0.66 amperes. Let's see the next problem. The circuit is given R1, R2, R3, R4, R5 and the potential difference is 3 volt. R1, R2, R3 are equal to 3 volt and R4, R5 they are equal to 0.5 volt. Now he asks you to calculate total resistance. We'll find out now. Check that here DE. If you consider that DCE, here DE is one junction. So at this junction DE, R1, R2 are in series. You can write given data. R1 is equal to R2 is equal to R3 is equal to 3 ohm and R4 is equal to R5 is equal to 0.5 ohm and the V is equal to 3 volt. Now we have to calculate the total resistance. So if you consider DE, at DE R1 R2 are in series. So at DE R1 and R2 are in series. So then how can we write the formula? Rs is equal to R1 plus R2. So therefore Rs is equal to R1, R2 they are equal to 3. So 3 plus 3. So it is equal to 6 ohm. So therefore Rs is equal to 6 ohm. Now this Rs is parallel to R3. Rs is parallel to R3. Then the resultant, that means Rp, it is equal to, what is the formula? R1 R2 by R1 plus R2. Here instead of R1 R2, Rs and R3. So Rs into R3 by Rs plus R3. So now substitute the values. Rs is equal to 6 into R3 is equal to 3 by 6 plus 3. So now if you simplify, this Rp is equal to 6 into 3, 6 into 3 by 6 plus 3, it is equal to 9. So 3 here, 3 times, 3 here, 2 times, so this is equal to 2. Therefore, Rp is equal to 2 ohm. So Rp is equal to 2 ohm. Now look at the board. So the resultant of these three is equal to Rp, that is 2 ohm. Now the 2 ohm and R4, R5, these three, that means R4 and here the resultant Rp and R5, all these are in series connection. So now R4, Rp and R5 are in series. Now what is the resultant? R is equal to R4 plus Rp plus R5. In the series connection we have to add simply. So then this is equal to R for 0. So this is equal to 0.5 plus 2 plus 0.5. So this is equal to 0.5, 0.5, 1 plus 2. So 3. Therefore total resistance R is equal to 3 ohm. Now we have to calculate total current. So I is calculated 3 ohm and potential difference is given, that is 3 volt. So current I is equal to question mark. So we know that as per Ohm's law, so V is equal to IR. So from this I is equal to V by R. So now substitute the values. I is equal to V value 3 by R value 3. So 3 is equal to 1 ampere. So total current I is equal to 1 ampere. Now we'll see the next problem. The circuit is given. Here the circuit is given. R1 is equal to 4 ohm, R2 is equal to 3 ohm, R3 is equal to 6 ohm. Here R2, R3 are in parallel and they are connected series to the R1 and the potential difference is 12 volt. He asked to calculate total resistance, total current and potential difference at R1. So first we have to calculate the resultant of these two. These two are connected in parallel. So the resultant resistance of R2, R3 we have to calculate. The resultant is then series to the R1. Then R1 and resultant of R2, R3 gives the final resistance of the circuit. So now given data, R1 is equal to 4 ohm, R2 is equal to 3 ohm, R3 is equal to 6 ohm and V is equal to 12 volt. Now R2, R3, these two are parallel to each other. So R2 is parallel to R3. Then the resultant RP, the resultant of these two in parallel connection is equal to R1 R2 by R1 plus R2. So here instead of R1 R2, R2 R3. So R2 into R3 by R2 plus R3. Now substitute the values in this formula. So now Rp it is equal to R2 value 3 and R3 6. So 3 into 6 by 3 into 6 by 3 plus 6. So this is equal to 3 into 6 by 3 plus 6, 9. 3 here 3 times cancel. 3 here 2 times cancel. So therefore it is equal to 2 ohm. So what is this? Rp. So Rp is equal to 2 ohm. Check the connection here. This is R1 and the resultant of these two it is equal to Rp. So Rp is connected here. So now this is Rp. So now these two are in now series connection. So therefore R1 and Rp are in series. So now when the two resistors are series, when the two resistors are in series, then the resultant resistance R is equal to R1 plus Rp. R1 plus Rp. R1 is equal to 4 ohm plus Rp is equal to 2 ohm. So total it is equal to 6 ohm. So therefore R is equal to 6 ohm. So this is the total resistance in a circuit. So therefore total resistance R is equal to 6 ohm. Calculate 6 ohm and V is given 12 volt. So we have to calculate total current I is equal to question mark. So as per Ohm's law, so we can write V is equal to IR. From this, I is equal to, send that side, then V by R. Now substitute the values. So current I is equal to V is 12 by R is equal to 6. So 6 2 times cancel. Therefore, the current I is equal to 2 amperes. So therefore, total current I is equal to 2 amperes. See question number C, potential difference at R1. we have to calculate potential difference at this R1. So R1 value 4 and the current passing through this circuit is total current 2 amperes. So we know that R1 is equal to 4 ohms and the current total current I is equal to 2 amperes current. Same amount of current passes through R1. Then V is equal to V at R1 is equal to question mark. So V at R1 is equal to, so as per Ohm's law, V is equal, I also can write that I into R1. I it is equal to 2 and R1 value is 4. So 2 4 8. So this is 8 volt. So V R1. Therefore, potential difference at R1 is equal to 8 volt. So therefore, the potential difference at R1 is equal to 8 volt.